Ocean currents are driven by many different forces. Heat from the sun can heat the top of the water, and then tidal forces, like those from the moon pulling on the earth, can change the way the water circulates. Also, how salty the water is changes how it either floats or sinks in the ocean. So we're going to demonstrate how these different types of water will interact. So here I have some dyed blue water, which is very, very salty. So high salinity, colder water. And Evans here is going to make some hot water that we put some red food coloring in. And we're gonna pour those into this bucket of fresh water, which represents the oceans. And we'll see how these different ocean currents are going to set up. So I'll pour this cold water from the side here.
Are you ready?
Let's go. So you can see that the cold water sinks down to the bottom. It's very saline, it's very salty, and so that makes it more dense than this warm water that is riding on the top. And then you can see the different circulations and the interactions between that cold and warm water in this bigger body of water, which represents the ocean. So you can see that this cold, salty water is so dense that it just rides below the whole rest of the ocean water that we already have in this bucket.
I like that I can see it rebounding off the sides of the tub.
And interacting again, that's right. So overall, as the Earth system, it heats up at the equator, and that's the warm water that's riding on top, and then by these currents, it gets transported to the poles where it sinks down and gets cold and saltier, and then creates this whole circulation that happens all over again.
Doolin, when I'm looking down here at the side of it, I can almost see ripples on top of the salty blue layer, similar to the ripples that you would see on top.
Oh, you can. Yeah, it's the same. That's great. So the same forces are interacting throughout the whole water column, and you can see that in this really simple experiment you can do yourself.